beaker, there is almost 100 cubic centimeter of HCl, right? And then its concentration is 0.9, which means it is it actually has less particles per unit of solution. Yeah, I can say it is less concentrated in this case. I'm not sure, but it doesn't matter. So what actually happens is that concentration means the amount of solute that dissolve in a solvent, or the number of moles per liter of the solution, right? So let's say maybe we have beaker one, and then we have beaker number two, and then here we have almost those particles, and then here we have those particles. What we can conclude is that this one is okay. This one is more concentrated, right? And then this one will be less concentrated. The reason being, for beaker number one, we have less particles per liter of a solution. We have almost 4 particles in that solution. But for this one, I think there are even more than 10. So it is more concentrated because we have more particles per liter of the solution. And this is where also pH will enter. pH will also talk about the concentration. But okay, let's deal with the question now. 8.2.1 said define concentration in words. You know, I told you the definition, the amount or the number of moles per liter of a solution, or the amount of a solute that dissolves in a solvent per liter of the solution. So you know that solvent is actually your liquid, and then solute is actually the particles such as sugar, milk, and I mean the powder milk and all those that are in powder. All right. So now 8.2.2 says calculate the number of moles of HCl present in 100 cubic centimeter of this solution. But what you need to take from here, is that you don't work with cubic centimeter. You rather work with dm cube, right? And then in this conversion, you need to know that cubic centimeter is equal to, no. The conversion that you need to know is that 1 dm cube is equal to 1000 cubic centimeter, right? And then you need to also know that dm cube is also equal to 1 liter, or 1 dm cube is equal to 1 liter, which means 1 liter is equal to 1000 milliliter, which means cubic centimeter and milliliter are equal. Those conversions are equal. This is what you're going to work through with. So in most cases, they can give you in liters. They'll give you in liters. Once they give you in liters, so it means you can just use what? Once they give you in liters, it means you can just use liters and assume that liter and cubic decimeter are equal there. So right there, I think we're on the same page, right? Now, because you have the concentration and the volume, you can go straight and find the number of moles. You have a formula which says N is equal to C is equal to N over V, right? And then C is your concentration, which is 0.9, is equal to N over. Here you do the conversions. You are going to say volume in dm cube will be equal to 1 100 divided by 1000, of which the two zeros will cancel each other. You'll be left with 1 over 10, which is equal to 0.1. So here I'm going to substitute 0.1, and then N, or the number of moles of HCl, is going to be, what do you get? 0.9 multiplied by 0.1.
0.09.
0.09 mole. Those are the number of moles of HCl that are present in that solution, right? Now, in most cases, or in all the scenarios that we are going to work with, these are the initial number of moles that you have. Because whenever you're working with pH, or you are looking for pH, or you have pH, you are doing back titration, you are going to need two number of moles in order to get the other one. But you will see. So this is your initial number of moles. This is the number of moles that you have before the reaction was done, right? Now, we're going to start the reaction. All of the Mg, all of the 100 cubic centimeter hydrochloric acid solution is allowed to react with 3.5 of unknown metal carbonate with MgCO, right? According to the balance equation. Now, I want to highlight something. Here you have your MCO, which is in a solid state, right? You can see that it is a solid because of the small s. And we call that compound a precipitate. Once it is in a solid, or if it's a reactant that is in a solid state, it is called a precipitation. And then a precipitation, it is your limiting reagent always. Why? Because assume that you have your HCl, which is in a liquid, right? Which is 100 cm3 HCl, right? In this HCl, I'm going to dissolve maybe sugar. I'm going to assume that my MgCO is sugar. MC, oh, not MgCO, so MCO3. I'm going to assume that it is a sugar. When I dissolve it inside, or when I pour it inside, it's going to dissolve, right? Once it dissolves completely, it will be like a liquid. You will no longer see the MCO3 inside there, which means it has been used completely. You know that when you're making tea, once you um do what? Once you have completely made your tea, you no longer see the sugar inside, but you see the mixture of sugar and your water, which is the tea, right? So which means the sugar is dissolved completely. The sugar was the limiting reagent. So always, once you have a solid as a reactant, it is the limiting reagent, right? All right. So now what we're going to do, I want to assume as if you guys are good with making up equations. Do you guys know how to make up an equation or a a chemical equation? I need someone to respond to me first.
No, sir.
Okay, yeah, it's fine. I get that. So let's talk about it first before we move, because it's also important. For your level, um, sorry about that. For your level, you are going to deal with reaction of acid plus a base. Because in grade 12, they assume that you know how to make reactions. So they won't give you those thing of they won't give you those things of maybe metal and acid and whatsoever. They won't give you those. So this one you produce um water and salt. You produce water and salt. When you mix an acid and a base, you produce water and salt always. But when you mix an acid plus a carbonate base, carbonate base, you produce um carbon dioxide, which is CO2, plus H2O plus salt. This is what you do, right? Now, I'm going to refer you to only few polyatomic ions that I know. The other ones, you'll get them from the predictable. So in the predictable, you have things like group number one, group one, which has things like Na, right? So Na, it has a positive ion, you know that, which means it is able to lose only one electron. So you need that thing. And then you also have group number 7 or group number 17, whatever you understand it as, which have things like Cl. It is able to accept only one electron to achieve the octet rule, you know that. So which means it has a negative there. Then you have things like on group number 2, I'll say G2, you have something like calcium, which is 2 plus, which means it can donate 2 protons or 2 electrons. It can donate two electrons there. So it is 2 plus, right? Because it is in group number 2. Here I'm talking about the group number. If it is group number 1, it is positive. And then if it is group number 2, it is 2 plus, right? And then if it is what about if it is group number 6, G6, something like oxygen, right? So for oxygen, it's going to be 2 minus. That is oxygen because it can accept 2 electrons in order to achieve the octet. You know, the structure of oxygen is something like 1, 2, 3, 4, 5, and 6. This is the structure of oxygen. It only needs 2 electrons to achieve the octet, right? But when I no longer you no longer talk about the octet. So how about elements that are in group number 3, especially things like ion, right? So for ion, it's either they will either say ion 2, or ion 3, something like this. Ion 1, 2, 3. So once they give you ion 2 like this, they actually means that your ion can can donate 2 protons, 2 electrons, which means it is F2 plus. Then if it's I3, it means that your ion can actually donate 3 electrons there. It is F3. So for those things like even copper, Cu, they will also refer you to it like this and this. And that is what you need to build a compound. But what about the polyatomic ones? Things like the ones that I know, these ones you need to know them by heart. They are not in the predictable. You have OH minus. This is the first one. The second one, you have CO4 2 minus. Then the third one, you have P. What's going on? So for this one, you have PO4 3 minus. Yes. This is the other one that I know. PO4 3 minus. And then you also have things like NO3 minus, right? These ones you need to know them by heart. Right. But okay, let's use them in building a compound so that you will see how you do it. So guys, can someone please admit people who will be entering, please, so that we don't lose time on that. So if you want to build a compound, let's say you want to build um, calcium carbonate. You want to build calcium carbonate. Oh, I also forget about the carbonate one. For carbonate, it is CO3 2 minus, right? Yes, yes. CO3 2 minus. That's carbonate. You want to mix a carbonate or calcium carbonate and sulfuric acid, H2SO4, right? So which means you're going to say H2SO4 plus CaCO3, right? Then for the product side, you need to break them down. The way you break them down, you need to know that hydrogen is in group number 1. So which means it is H plus. Hydrogen is H plus, right? And then which means these two, these two will come back here and make SO4 2 minus. This is a polyatomic ion that you need to know by heart. By heart. Now, you know that carbonate, this one, your carbonate or your carbonate is made up of calcium and carbonate ion itself. You are going to say Ca, but you know that calcium is in group number 2, which means it's going to be 2 plus. Now, a carbonate, we said it is CO3 2 minus. But someone will be wondering, where is the 2 here on calcium? Where is the 2 on calcium? Is fine. Let me show you. So, because it is Ca2 plus and CO3 2 minus, when I mix them, these two will come to this side. And then this one, the negative 2 will come to that side, which means at the end I have 2 calcium 2 open brackets CO3 2, right? This is what I have. You cross multiply, but you don't take care of the negative signs there. They just indicate the ions. So what you will see is that you have the same basis, or you have the same subscripts, which is 2 and 2. So once you have the subscripts like that on a compound that is made up of 2 ions, you can just simplify that compound into CaCO3. You are allowed to do it like this. So this is what you're going to do in all cases. Once you have a subscript in 2 compounds, you simplify and make it a single thing there. Right? Now let's see. Let's look at this one. What I'm going to advise you, according to physical sciences, unlike charges, they attract each other. Then like charges, they repel each other, right? So what you're actually going to have, you're going to have in this one, which is CO, O, and O, you have 1 carbon and 2 oxygens, right? You are going to take 1 carbon and 1 oxygen and 2 oxygens. This will form carbon dioxide. Now you will be left with 1 oxygen. 1 oxygen is left. Then you know that oxygen is in group number 2, is 2 minus. oxygen itself. So which means now you already have CO2, because here you took a carbon and two oxygens to make a carbon dioxide. Now you are left with one oxygen there, which is in group number 2. Okay, now what else do we form? We form carbon dioxide. Now we need water. You have this hydrogen here. You have this hydrogen, which is H plus. When you add H plus and O2 minus, this 2 is coming to bond there, and then you have H2, and then oxygen will be left alone, and then that is H2O. So you have H2O right there. Now your salt will be everything that is left. Your salt is actually going to be this calcium there, and then the sulfate ion there. So which means you're going to have your salt as Ca2. This 2 is coming to bond there, and then SO4. These 2 will come and bond there. You have SO4 2. Now, because you have the subscript, which is the same both sides, you simplify it and have CaSO4. This is your salt that you have. Now you look whether your equation is balanced or not. But let's take if we have a simple acid and a simple base. You have HCl plus NaOH. This is an acid and a base. We said you form a salt and water. The best way that I will advise you is form the water first. First form the water before the salt, because if you remove the water, everything that is left, it is now your you are salt right there. So when you break this down, you're going to have H plus and then Cl minus, and then for N it's Na plus and then OH minus. We said unlike charges attract each other, like charges repel. So it is impossible for the chloride ion to attract the OH ion. It will never happen because they are like charges. They both have negative charge. So what is actually going to happen, your cross multiplication will happen in this way. Right? So what you will see, you have a hydrogen here. You also have a hydrogen there. You form H2. And then you also have an oxygen there. Then you have H2O, right? So which means you have your water, which is H2O. Now, everything that is left, it is now your salt, which means you have dealt with H2O there. And then your salt is simply NaCl. That is it. That is what you have there. So I hope it makes more sense. But I'll give you other ones that you will do for me. I'll send them on the group. So that is simply what we have. And also here, let's see. This one is actually a carbonate base mixed with mixed with HCl there. So I think we will need to find out what type of metal is this one. And in most cases, a carbonate base is made up of a metal, because you have the ones that I recognize. You have CaCO3. This is a metal. And then you have Na2CO3. It is also another one that I recognize, and etc. and etc. It's fine. Now, let's get back to our statement. Oh, I was still saying 100 cubic centimeter of HCl was allowed to react with 3.5 of unknown metal carbonate. So which means because we are given the mass, it is in powder state. and then which means it is our limiting reagent, you know that, right? Now, they said, the equation is balanced. Make sure that the equation is balanced always. The hydrochloric acid is found to be in excess. You hear the statement now. The hydrochloric acid is found to be in excess. But for someone like me, it was not important because I know a, a precipitate is always the limiting reagent. And another thing that you need to note, if I mix a liquid with a solid, my volume is not additive unless stated otherwise. Because in this case, you are going to add, because they said they are allowed to react. Now, we are going to react metal carbonate and HCl. Your volume is not additive. So that is what you need to know. Your volume is going to remain as 100 cubic centimeter for this reaction. For this reaction, you don't add because that is a solid. We assume that a solid will not increase the volume right there. Because our volume we're talking about in aqueous state. Then let's read the statement as we proceed. The HCl was found in excess, which is HCl. Now the excess HCl is neutralized by 25 cubic centimeter of sodium hydroxide solution with concentration of 0.8 mole per cubic decimeter. So when they talk about neutralized or neutralization, they're talking about titration, because when we neutralize something, we need to reduce its strength. You know that HCl is a strong acid. This is a strong acid. I cannot make anything with the strong acid. It is very dangerous. So in order to use it, maybe in case I'm making a medication, I need to first neutralize it so that it becomes weak, right? And then in this case, they neutralized it by adding 25 cubic centimeter of sodium hydroxide with the concentration of 0.8 cubic centimeters, mole per cubic decimeter. So neutralization is basically titration there. Okay, let me remove this. And then you are given the reaction. I want to talk about something now. I want you to look in my reaction number 1 and reaction number 2. In those reactions, what you will see is that in both reactions, you have HCl. So what will happen? In the first reaction, your HCl has reacted, but it was the excess. Excess, it is the one that has been left. So which means it was very strong. That's why it was left. So we further made another titration by adding it with sodium hydroxide, which means there is a relativity between the two, right? Which means the number of moles of HCl here, it is the initial number of moles. Those are the initial number of moles and are actually the ones that we have calculated in 8.2.2. The number of moles there are the initial number of moles. Now, in the second reaction here, the number of moles that are left, or the number of moles that we will get here, we call them the excess. It is the number of moles that are in excess hydrochloric acid, right? So the most important thing that we will need the number of moles of hydrochloric acid that have reacted. Because, okay, one, we have initial, and then, okay, let me not do that. And then we have initial, and then here we have the excess. Excess actually means the final. I can just say final because excess, it is after the reaction has been done. So which means if we have the initial and final, we can find the used up number of moles, or we can find the number of moles that has been used in the reaction or that have reacted in case. And we use the formula which is N number of moles that have reacted will be equal to number of moles or initial number of moles minus the excess number of moles. Or you can just say the final, initial minus final, which is the change. Change is it is the reacted. Doesn't matter however way you interpret it, there it's fine. Now, let's see if for the second reaction, before we come to answer this question, let's first analyze whether we can get to this point. Because now we have the initial number of moles there. We have the initial number of moles. Let's see if we can get the excess number of moles of HCl, right? And then we'll get them here in this equation. Let's read our statement again. We have 25 cubic centimeter of sodium hydroxide, which is 25 NaOH, with the concentration of 0.8. Here we can find the number of moles of sodium hydroxide by going and by using the equation concentration of sodium hydroxide is equal to N over V, right? But you know that we work with cubic decimeter. That is what I told you, which means you are going to convert this. V will be equal to 25 divided by 1000. And then for this one, I don't know. What is the conversion of this one?
0.025.
0.25 cubic decimeter. This is what I have. Right. So now I have the concentration, which is 0.8. And then I don't know the number of moles. I need them. And then but I have the volume, which is 0.025 right there. I can get the number of moles. What is the number of moles of sodium hydroxide? You just cross multiply
0.02.
mole. Those are the number of moles of sodium hydroxide, not hydrochloric acid. But I need the number of moles of hydrochloric acid. What am I going to do? I'm going to do the mole ratio. The mole ratio actually means when I do the mole ratio, it means I'm reacting the two of them. That is why the mole ratio indicates a reaction between the two, right? So which means I'm going to say number of moles of sodium hydroxide, NaOH, react with number of moles of HCl. What is the ratio? The ratio is 1:1. So for every 1 mole of sodium hydroxide, 1 mole of HCl will be used to react. So for every number of moles of sodium hydroxide, we will also need 1 mole of hydrochloric acid there to react. That doesn't matter. But you just need to know that the mole ratio, we use it for the reaction to indicate that they are reacting. So because the ratio is 1:1, I'm going to say number of moles of NaOH are equal to number of moles of HCl, which is equal to 0.02 mole. And then what is this now? This is the number of moles that were in excess. The number of moles that were in excess. Right. Okay. Let me move it down there. Mm, So we said in order to find the number of moles that have reacted, we need the initial number of moles, and then we subtract the final number of moles, or the number of moles in excess. Then the problem is sometimes what you are going to get here, it is going to be a negative number. Sometimes it will be a negative number. That is why your teacher sometimes, or some other teachers, they will advise you to first use the excess here, and then you subtract the initial there. It is also one and the same thing, because you know that number of moles are not negative. We don't talk about a concentration that is negative, a volume that is negative. Number of moles can never be negative, right? So, okay, we had the initial number of moles, which was 0.09, right? And then we subtract 0.02 moles. What do you get here?
Zero comma 0.07.
Okay, we get 0.07 moles. Here we are fine. We have the number of moles of HCl that have reacted, right? So, listen, once you have the number of moles of HCl that have reacted, what were they reacting with? I hope we will all agree that they were reacting with metal carbonate right there. Those number of moles, which are equal to 0.07. I will show you how. Firstly, we had the initial, or from this question, we had the initial, which was 0.09 moles. Those were the initial, right? And then we added 3.5 of the metal carbonate, and then the reaction was completed. We find that HCl is in excess, and then that excess HCl, we further reacted it with sodium hydroxide and find the number of moles in excess, which means during the reaction with metal carbonate, the number of moles that have reacted with metal carbonate were 0.07 right here. This one. So once you're in a scenario like that, because we said these are the number of moles that have reacted, you are going to do a reaction again, or a mole ratio again, of the number of moles of metal carbonate and hydrochloric acid again. So which means you are going to have again NMCO3 react with NHCl. Just that we don't know the mole ratio. The mole ratio. What is the mole ratio? Mole ratio. The mole ratio is 2:1, or 1:2. For every 1 mole of metal carbonate, 2 mole of HCl was being consumed right there. So which means it is 1:2, right? And then what is the number of moles of metal carbonate? I don't know. I'm going to say MCO3. Then what is the number of moles of HCl? 0.07, right? Which means I'm going to cross multiply. And you will see that when I cross multiply here, I'm going to get 2 number of moles of, okay, just in case, at the end, you're going to say NMCO3 is equal to 0.07 divided by 2, because this one will remain as 1. And then here, number of moles of metal carbonate is going to be like 2 NMCO3, and then I have to divide both sides by 2. Divide both sides by 2. That is why I'm dividing there. Just that I'm not good in maths. What do you get here?
0.035.
0.35 moles. Okay. Now I have the number of moles of metal carbonate. While I have the number of moles of metal carbonate, what I'm going to do, I was given the mass, which was 3.5, if I'm not mistaken, 3.5 grams, right? Now I have the number of moles. What do I actually need? I need, what was the question? Because we didn't even, but in our question, we are going to need metal M, right? Determined by calculation the symbol of unknown metal, which is M. And then we have MCO3, right? So we need metal M. We'll find it through the molar mass, obvious. So what I'm going to do, I know that MCO3, it is made up of metal plus carbon plus three oxygens. And then the molar mass of the metal, it is just M. I don't know. Then carbon, it is 12. And then oxygen, there are three of them, so it's 16 multiplied by 3. So it is also important to know the molar mass by heart so that you don't waste time in exam looking at the periodic table and so on and so on. So just know them by heart. 16 times 3, I think it's 48, something like that. Yes, it's 48, obvious. So what you will see here is actually going to be M plus 12 plus 48. I think this is going to be 60, if I'm not mistaken. Is it? Yes, it's 60. So of metal carbonate that you have, of the metal carbonate that you have. All right, but you need the metal itself, or what metal is it? So I'm going to say NMCO3 is equal to M over M, right there. All right, what is the number of moles? It is 0.035. It's equal to 3.5 divided by M plus 60. This is what you have, M plus 60. So what I can advise to do, this is just maths. Well, now you know how to work maths, but for me, maths is complex. I struggle with maths. So what I was going to do, I was going to cross multiply here and get 0.035 multiplied by M plus 60. This is what I have. And then I have 3.5. Then I divide both sides by 0.035, 0.035 right there. And then I will be left with M plus 60 is equal to, what do you get this side?
$100.
You're going to get 100. All right. So now you can just transpose 60 to the other side, and then you get M is equal to 100 minus 60 is simply 40. That is what you have. That is metal M. Now you are going to the periodic table to look which one has the molar mass of 40 from the periodic table. For me, I'm very sure that it's calcium, Ca, because I know that calcium carbonate has a molar mass which is equal to 100. And then this one, we said it is 60. So when I subtract 60, I'll be left with 40 there. Yes, so there you have your 7 marks, and then you are fine just like that. This is what you used to do in grade 11.